In this example, we will solve the differential equation y times sine of x plus e to the y plus the factor x times e to the y minus cosine x plus 1 times y prime equals 0. Since this is not linear nor separable, we need to check if this is an exact equation by comparing m sub y and n sub x, where m is y times sine x plus e to the y, and n is x times e to the y minus cosine x plus 1, the coefficient of y prime. Checking this, we get that m sub y is the partial derivative with respect to y of y times sine x plus e to the y. Holding x constant and taking the derivative with respect to y, we get sine of x plus e to the y. For n sub x, we take the partial derivative of x times e to the y minus cosine x plus 1 with respect to x, giving e to the y plus sine of x. Since m sub y and n sub x are equal, we can conclude that this differential equation is in fact exact. So there exists some function psi of xy such that psi sub x equals m of xy, which is y times sine x plus e to the y. And we can begin to build psi of xy by integrating this with respect to x, to get that psi of xy is equal to the integral of y times sine x plus e to the y dx. In integrating here with respect to x and holding y constant, we'll get y times the integral of sine x with respect to x, which is negative cosine x, plus the integral of e to the y with respect to x, which is x times e to the y. And in the last term, we'll have some constant of integration. But remember that constant of integration is just constant with respect to x. It can be a function of y. So we get that psi of xy is a function negative y times cosine x plus x times e to the y plus a function h of y. And to find h of y, we'll compute psi sub y, which we know is equal to n of xy, since this is an exact equation. Psi sub y, using the psi we just found, is the partial derivative with respect to y of negative y times cosine x plus x times e to the y plus h of y. Taking the derivative of negative y times cosine x with respect to y gives negative cosine x, plus the derivative of x times e to the y with respect to y is x times e to the y again, and the derivative of h with respect to y can be written as h prime of y. And we know that psi sub y is equal to n of xy, which is x times e to the y minus cosine x plus 1. So setting negative cosine x plus x e to the y plus h prime of y equal to x times e to the y minus cosine x plus 1, we can conclude that h prime of y is equal to 1. And thus, by integrating, we get that h of y is equal to y, up to a constant c. So with h of y equal to y, we get that psi of xy is negative y times cosine x plus x e to the y plus y. And we can conclude that the implicit solution to our differential equation is negative y times cosine x plus x e to the y plus y is equal to some constant c.